I talked about theft as well, but this is a number that I got online. I don't know if it's correct, but they said there's like in retail in general, there's like almost $10 billion is lost annually. I don't know how they actually estimate it because that's pretty hard to estimate, but we'll just go with that number.
Danny is a recovering data scientist who has moved over to the dark side of machine learning and data engineering in the past 2 years. He currently runs data with #DataWithDanny community. I'm not sure if that's on LinkedIn, Danny, with over 4,000 aspiring data professionals. And he's working towards his vision of creating a scalable virtual data apprenticeship program to further spread his knowledge and expertise. So today, Danny is going to share with us his experience on retail data science in Australia. Over to you, Danny.
Awesome. Thank you so much, Clifton. I hope everyone can hear me properly. Awesome, cool. I'm getting some thumbs up. Thank you so much for having me here today. I'd like to thank Jesse for inviting me to come and speak. Thanks, man. It's really cool to get in front of everyone here and just kind of share more of my knowledge around retail data science in Australia, at least. And hopefully you guys can learn something from this one. If you have any questions at any time at all, just hit me in the chat. Someone can let me know if I'm missing any questions as well. So I'll just jump straight into it. So I'm going to share my screen. Okay. Cool. All right. My thing is blocking half my screen, so I'll try and figure out what's going on. Okay. So it's kind of just speeding up really quickly. Let me go back. All right. So let me preface this with a little bit of background about myself and where my experiences have led me in Australia to work more in retail and get a better understanding of where I'm coming from in my experiences. So when I first started as a graduate, I started at Quantium, working in the data analytics team specifically for Woolworths as a client. So I spent 2 years there doing pretty much end-to-end digital marketing at a one-to-one level, looking at all of the transactional data and trying to figure out which customers to target for a specific marketing campaign. This was mostly on email, but we also started dabbling within Facebook campaigns at the time. This was back in like 2014 or so. So it's been a while, and I'm sure the digital marketing has advanced quite a lot. After that, I went to CBA and I worked within the digital team of CBA. I also worked with Jesse. Jesse was within the data science realm also. And essentially I was working on doing mostly marketing models again to try and target specific customers and get them to do some sort of action within a certain time frame. So very much the same thing, but now using machine learning. And I started dabbling more into using machine learning in production systems to target customers and get them all the way through the system. So that was pretty cool. And after that, I moved back to Woolworths as a contractor, and I worked there for around 18 months, helping them set up a lot of their cloud machine learning platform, as well as starting to move more into the data engineering space, where I was helping them build out a lot of the data assets that they were using to feed a lot of their machine learning models and some of the ML ops also. So, and that brings us to around here where I can start talking about retail in data science, or retail data science in Australia. Okay. So where is data science used in the retail industry? So I'm just going to rattle off some of these ones, but there's going to be direct marketing models, product offer recommendations. So imagine like your Netflix recommender or your Amazon product recommender. Multi-channel media sales and attribution was an area that I focused on a lot when I was working at Woolworths for the second time. So we were trying to pull in a lot of data from all these different sources and trying to figure out where customers were seeing specific targeting. There's also range optimization. So range in this sense is around what products Woolworths is storing, or what products are they selling within different stores. So we'll talk a bit more about that. Supply chain logistics, it's quite obvious where we can use data science for that. customer sentiment and surveys, digital product development. A lot of anti-theft applications were starting to be developed at the time also. And I'll finish off just talking about whether we should be using chatbots within retail and also smarter robots in that sense. And I'll talk through some of the more left field style applications that I have started seeing within the retail industry. And we can probably discuss some of your ideas as well. Okay. So this slide is nice and simple. Direct marketing models are here to stay. A lot of the marketing, so pretty much in retail, there's a big focus on loyalty programs. So everybody wants to get your customer ID, see what you're buying, see what stores you're hitting, trying to mine all these different patterns from the data to try and predict whether someone's going to be influenced by certain offers, different emails on different channels. It's all around that typical marketing, direct marketing space. So some of these models might be Uplift models were really popular. These are essentially the marketing team might try and figure out, okay, this segment of customers is really good. The data science team will come in and try and help them build out some sort of experimentation plan. So then they can kind of randomly target an unbiased base for the first round, get the treatment data off the back of it, and then try and figure out good response models or uplift models to try and identify which customers we should be targeting to change their behavior. There's also, so uplift models would be based off different sorts of strategic objectives. So these could be customer acquisition, so trying to onboard new customers. Lapse and churn was a concept as well within retail. So you might have heard something called, there's like a recency, frequency, and I forgot what the last, it's called RFM, but I forgot what the M stands for. But essentially you want your customers shopping relatively frequently with you. So then you can make some sort of assumptions to say, oh, okay, if Jesse hasn't shopped with us for 3 months, for example, maybe he's lapsed, we'll send him $50 offer via email to see if we can reactivate him. So just these really simple tactical marketing strategies, we would use machine learning models to essentially get that done. The same thing with activation and cross-sell. So within Woolworths specifically, you might have people shopping at the supermarket, but you want them to kind of cross-sell them into the different banners under the entire Woolworths group. So you might have, there's different petrol, there's Big W, which are big box stores that sell all sorts of stuff outside of the regular foods and fresh food and everything. There's also some of the other products within Woolworths also included financial products. So these might be your pet insurance, health insurance, life insurance. There are a few other financial products also, but essentially we were using those customer behaviors within their shopping experience to try and figure out whether there are any relationship between them taking up another product. So I think I saw a message come up, but I can't actually, okay, I'll bring up the chat, keep it up here. Yeah, I think, oh, Matt's comment, reach, frequency, and monetary. I'll have to try and figure out. I can't remember what the M stands for, but it was definitely recency,
money.
Frequency.
It's the monetary. It's the monetary value.
Yeah,
monetary value.
Might have been like absolute value of like how much they're spending as well.
Money. Yeah, how much they're spending.
Right.
Yep.
Correct. Okay. Yeah, and some of the other strategies for the direct marketing you guys are probably familiar with, but essentially just trying to make customers buy more, spend more with you. But the crux of where data science is used within these areas is to effectively build your experimentation design. So then you can actually have some sort of causal analysis of, okay, did this intervention lead to a specific uplift in a certain metric that we're concerned about? This was, in retail, it's actually really difficult. The main problem is that most of the direct marketing and the marketing communications is still at a campaign level. So all of the reporting is done at a campaign level. There's always going to be customers who might receive multiple campaigns. So how do you control for that in an experimentation design perspective? So there were always problems that we were dealing with in terms of overcounting, double counting. Some customers might be in the control group for one experiment, but they're in the target group for another. How do you know whether there is any halo effect on those sorts of communications that actually led them to come into a store and buy something? So the most important part where data science was really supporting these marketing models was mostly in the measurement as well as in the targeting. So you could be doing those uplift models where you've got the treatment data with the responses, and then you try and identify who to target with a specific treatment. But we would also do natural propensity models where we just try and predict how often customers are going to come into a store, how likely are they to do a certain event within 30 days. And then on top of that, we would try and use that to unbias the customer base, the audience. So then we can actually go ahead and use that for further response modeling also. So it all kind of ties in together, but safe to say there's always going to be a data science component within that direct marketing space. The question would be, how well automated does it become? Because the biggest challenges for the data scientists that I was working with was getting the right data. There was a lot of problems building out their feature store, having efficient model training. I think almost every single data scientist within retail wants to build their own models, custom, bespoke style. So they go ahead and do that with the blessing of the business also. So these are the efficiency problems that I see within retail, where you'll also have multiple data science teams across the different organizations. So you might have one for marketing, one for loyalty, one for digital, and one for the operational side of supermarkets. And they all have different systems. They all have different modeling methodology, and it just gets really messy. So, but before I lose myself on that component, this is essentially where we would use data science within the direct marketing space. Okay, any questions so far? Nope, I'm going to move on. So this is probably one of the more focused on components now is product recommenders. So which products should we recommend to customers? So this goes beyond the step of just having direct marketing, where you might send someone a $50 voucher if they spend $100 and different things like that, to actually, can we personalize it down to one-to-one communications that say, Clifton, your top 5 products are on special this week. Here they are. And most of the time when we were doing the recommendations within the Woolworth space, it wasn't with additional targeted offers. Most of the time we would just kind of surface up weekly to say, oh, Clifton, the products that you've purchased before, they're on special this week. You should come in and shop with us. So it was more around awareness, and you could say like brand building, but I don't think it's so much of a brand building. It's more just keeping touch with the customer and trying to serve them the right sort of content that they'd like to actually help them come in and save money. So a lot of the time when we were in larger team meetings, a lot of the focus for retail was mostly, yes, we wanted to provide customers with a really personalized experience, but the underlying crux of it was to help them save money. So there's always this kind of balance between trying to help customers save money, as well as trying to get them to spend more money. So it was kind of a weird little paradox in that sort of sense. But when we think of recommendations of products, most of the time these would be, so in the past, Quantium actually built a product recommender for Woolworths, for their supermarkets and for different businesses also. I think they used lots of individual models to predict individual product propensity, and then they bundled it all together and did a ranking to just give you the surface of the top 5. So in the past, when I was working at Woolworths, they really wanted to learn more from it. So the big push there was to use collaborative filtering, matrix factorization, and different methods to actually learn across the space also. So it was a little bit interesting. Personally, I thought that the one-off, like those smaller models did the job. But there's always, so within retail, there's always a space for people to continually build on the stuff, even if it's working. So there's in retail, they also call it fast moving consumer goods. So FMCG, you might have heard of it. Literally, it moves really quickly to the point where if something is working, there would always be projects just to come in and rebuild the thing to make it work faster, even if it was working fine. So there's always the mindset within retail is very different to other traditional machine learning places where if something works, you just kind of keep it in production and then tweak it every now and then if you can prove that it would work better than what's existing. Sometimes in retail where there's not so much structure, you would just get all these projects span up to replace the existing thing without a real proof of concept being done also. So it's just another thing to keep in mind.
Danny?
I see a quick. Oh, yep.
Yes. Sorry. You're just about to answer the question. We have a question from Puneet.
Yep. So what algorithms you use to scale the product recommendation? Usually the standard algorithms are not very scalable. Yep. Given the mass scale of the retailers. So the one that we helped them deploy within their data science area was just a straight, what do we do? We used ALS on Spark. So it was, they did something funky where they wanted to kind of, so normally when you think of the matrix factorization and the ALS, you would just have one, so for each customer, you might have all the products and then you just get like either a 1 or 0, whether they've purchased it or not. Maybe you would play around with the score to give it a bit more information. So the data scientists spent a lot of time trying to represent that, the thing that would actually get passed onto the algorithm with some custom scaling within there. So it was a little bit interesting. So they would apply their own custom weighting to, has a customer purchased this product? How often did they purchase it? Do they purchase it at multiple stores? All these custom metrics were actually used, but we were just using Spark to scale most of it. So it was pretty straightforward from that point of view. Okay, but they're also starting to scale out not just products, but there was a push in the last 6 months that I was there that people actually, they wanted to recommend more things to customers. So they were recommending offers to customers was something new that they tried doing. It wasn't using a lot of machine learning per se, but they were just doing it almost roundwise. So they would have an unbiased base, target people with randomly allocated offers, use that to train new models, and then they would just iteratively go through that instead of maybe blowing it up with a contextual bandit solution, for example. So I would still say that the offer recommendations and the other stuff within retail is still, I would say, an immature space. They have a lot of data, but there hasn't been a lot of very robust solutions out there where they've actually gone in and put that into production.
Jenny, I have a question
Yep.
regarding the recommendations are displayed in which channel? Is it on the website with a registered login user, or is it through email or any other channels?
So this is actually a really good question because most of the customer interactions are going digital. So what we wanted to help them out with was to productionize their product recommendations and store it in one place where you can kind of access it from wherever. So they actually had APIs that were plugging into their front end on the digital mobile app side, where if you signed in, you would actually see your top 5 recommendations across, let's say Woolworths, for example. But you would see it on your mobile if you signed up and logged in online when they were doing Woolworths online, when they're doing the shopping. You'll also see the same products will follow you in there as well as in the email. So they were essentially using the same outputs for multiple different locations. I think that from my perspective, I guess it makes it a bit more consistent when you're a customer. You wouldn't want to see like 5 different sets of product recommendations on different channels in a sense. So I think that was a good thing that they were trying to do there. But yeah, so sometimes they didn't even recommend products. They also recommended recipes online. This was specifically for the online store, but they would kind of pop up these like, oh, you've purchased potatoes, carrots, and beef before. You should try like a beef roast, and then they'd actually surface some sort of recipe. So I think that was pretty innovative, but it was also like a very niche proof of concept sort of thing as well. Because the thing for me is, how would you measure the uplift of that sort of initiative? It's very difficult to tie it back to a real business outcome. Do you tie it back to clicks and impressions and different things like that? That's another problem. So to talk about that is where that multi-channel, multi-touch digital attribution comes in. So in my time when I was working with Woolworths, me and another engineer, we essentially designed their entire backend for their platform, which is now called, I forgot the name. I think it's called Cartology, but they're essentially trying to sell Woolworths paid digital media, all the different impressions, to their customers, who are the suppliers and the brands who own the products that they want to sell to individual customers. So there was a big push to get a better understanding of how much did each advertisement in a specific channel actually contribute to a customer's sales outcomes. So I think there's a saying where it's like, all models are wrong, only some are useful. I think it was George Coase, something like that. But that's definitely the case within this sort of attribution space. Literally, you can't attribute anything with 100% confidence. Anyone who's doing so is probably lying to you. But what we would do was we help them build out a data lake where you can just have everything coming into one place. We had streaming data from their digital, from their website and their mobile apps. We had Google batch data coming in terms of all the Google ads and the impressions across their different assets. So you might have on YouTube might be one asset, Gmail might be another one, search will be another one, paid search will be another one. But this was mostly within the digital space. A lot of the models that the data science team built were using most of that data. What we wanted to do was kind of house all that data so they could very easily extract what they needed in a very concrete way. So we designed them essentially like an event store to go in and pick out whatever time series worth of events that they were looking for in a very structured way. So then they can look at different windows if they wanted to. They can pass in different window functions if they wanted to perform different aggregations over different levels. It was quite nice. I'm not sure if they're still using it in terms of how we designed it, but we deployed it mostly on, I think it was on Spark, and then also mirrored it onto BigQuery. But it was pretty interesting to see what they can do with it. So a lot of the data science teams would essentially take, let's say, all of the DataRobot employees were Woolworths customers, for example. We would build up features of what sort of campaigns did you see in different channels. Some of the features might be how many campaigns in terms of absolute number did you see? How many unique channels did you see? All of these different things would essentially bundle up and be used in a model to try and, I think they were trying to do like a regression model on the actual sale amount of customers. And then off the back of that, they wanted to, I think they used Shapley values to try and explain the individual contribution of each feature. So it was a relatively fragile model, but it was still impressive to see that they could go end to end and still pull out some sort of story out the back of it. And then that's essentially the model that they're going with to sell the paid media. And that's how they're pricing it. So it's pretty interesting as a from the technical side, because we provided them the data and gave them some sort of guidance on what they could do with it. And then the data science team convinced the business to go along with their plans and end up using these models for a live product. So I think it was a pretty cool story when I went through most of this myself. Any questions on this one? Okay, I'll move on. On this slide, it's everything is going on mobile. So you might have seen Woolworths doing a big push for they've got an online shopping app, as well as a loyalty app. And it's the same with Coles and Flybuys, which is the loyalty arm of the Coles group as well. So all of these are essentially another channel where Woolworths can contact their customers or retailers can contact their customers. It's the same when you think of online retailers like Iconic, ASOS, anyone else who's doing anything online where they have an app, they'll be capturing all that data in terms of how people are interacting with it. They will use that to track it back to the actual purchases at a customer level and essentially use that data to build features for whatever. So you could be using it for recommending products. You could do it for trying to get them to spend more. But most of the mobile focus was to, one, to actually have another channel to contact people, and two, to just get more digital, what we would call rich digital data, so then they could build more features from it. The challenge of having all the data coming in from the digital is that there's much more data than a lot of the traditional transactional systems can handle. So there was a lot of focus on actually building streaming architecture so they could actually consume the data almost real time. I think we got it down to, 30-minute batch processing when we were there. And I think that was starting to move to real time. But you could essentially, within half an hour, you could say, oh, I just launched my campaign on the mobile app. Here's my performance. And you could really turn around some sort of reporting really quickly to the business if you had some sort of really key commercial need for different campaigns that you were running. But most of the time when we think of mobile, yes, it's giving the customers a better experience in terms of, oh, you can go on your phone and buy from Woolworths and buy from Coles and get it delivered to you. But it was more of it's like almost like a thinly veiled plan to just have another way to reach you and get in front of you to make you buy more. But yeah.
Quick question. So on the data sizes, how much was actually used for like training models? Like, is it a gig? Is it 10 gigs? Is it a terabyte that you typically see?
Okay, so at the time we finished building an event store and a feature store for them, for the data science team to consume. The feature store, I think it had, I'll say 40,000 features. I think at one point they were storing it in wide format, which is really, really bad. So we helped them make it go into long format and then built them a different pivoter right at the end when they filtered down everything. But occasionally we'd see models being trained with, I think over there, they didn't really like to sample. So they would just try and do it on the whole data set. So it'd have like, I don't know, maybe if you think of customers, say 7 million, 10 million customers, so 10 million rows, 40,000 features, it's relatively huge. They actually the data science team spent a lot of time trying to, so we were all working on Google Cloud. Before the engineering team got on the ground, the data scientists had kind of taken over and they were building a lot of their own custom infrastructure, mostly on Kubernetes. They built custom Python queues to try and manage the parallelism of different training routines. But most of it was being done using like GBM, where they would just try and spin up massive machines, try and load as much into memory and just fit the thing one at a time. And they would just do it in parallel. But most of the time, the data sets were relatively huge. There were lots of times where data scientists would be training their model for a while, maybe like a few days on the cloud, and then something goes wrong and then they just repeat the process. So it was not great. And then if you also add in a lot of the digital data, it just kind of blows out the scale even more. So that was without the digital data. For the digital data, I think I can't remember the exact numbers, but there were Like we're handling it would be like a few terabytes, maybe a few 100 GB a day. I can't remember, but it was relatively big, and there were increasingly more digital volume coming through every day. But we actually helped them get it from, there's like another third party which was just sending messages directly into our queue, and then we would go full processing of the queue, put it into Spark processing in batch jobs, and then pump it out into BigQuery or into storage for people to use straight away as Parquet files. But it was, yeah, there's a lot of data. I think most of the time we would try and do sampling. So ideally we'd train models really quickly, get a really small sample and just iterate really, really quickly. And then every now and then, once we get the best model, then we'll try and fit it on the entire data set. But yeah, here they really liked fitting everything all at once. Okay. Any questions? No. Okay. So that's mobile. There's a lot of data in there, and it's really interesting, but it takes a lot of time to actually massage it into the right shape for the data science team to actually consume as well. Okay. So I'll talk about range optimization. So this is an area where I did not work in, but one of my good friends was the head of data science that focused on pretty much all of this stuff for most of his career. So I know enough to talk about it at a relatively high level. So for range optimization within Woolworths and for supermarkets specifically, if we start from the left, the question would be, what products do we stock in specific stores to match customer tastes and demand in the area? So they would be using elasticity models. They would try and cluster stores based off shopping behavior of aggregated customer groups. And they would also try and, I think this was more of a new thing that they were trialing, but they would have new products coming in and they'd try and help them design some sort of experimentation plan to kind of give them enough of a test to see whether they should continue buying that new product to serve to their customers. So it was different things like that in terms of stock, like which products and how many should they keep in certain areas. So for example, I live in Burwood in Sydney, which is there's a lot of there's a huge Asian population around here. In my Woolworths, they sell a lot of Asian goods, so Chinese sauces, noodles, and everything. If I go towards the northern part of Sydney, where there are less Asian population, I wouldn't see that as much. So there's all these different store clusters would be used to actually help out with the stock ranging of which products go where. So it's actually a really high leverage piece of work, because if you get it right, you can actually do really well in terms of selling the products that your customers want. But if you do it really badly, you could actually force customers to go somewhere else to buy their entire basket, and then you lose out on the money that you could have made.
Hey, Danny,
Okay.
Quick question. This is Puneet this side.
Yep.
So I would assume that as part of the results of range optimization, you would recommend a category manager or merchandising manager to remove certain SKUs, right? But from a business perspective, that might not make sense, because there could be a SKU with very high margin because probably the supplier would be giving funding, or a lot of reasons could be there, right? So how do you usually go about convincing the business team that is this a right decision, or how would you go about including those business understandings to your models?
Very good question. I personally would not have the experience to answer you. I can kind of have a guess of how it might go though. So a lot of the time, most of the buying decisions are business driven. I think the buying and the distribution across the different stores, they are still related. I'm not sure if the same, the category manager, the category owner actually determines that granular level of stock allocation to different stores. But they might, or at least they have to have the final sign off on it. So for sure, any data scientists who are working on this sort of analysis, they would really have to work very closely with the category managers to make sure that one, the message is going to be accepted in terms of like the business people aren't just going to push them to the side and say, oh, that's all good, but don't worry, we got this sort of thing. So I think most of within this range space, it's always dealing with different parties. So data scientists within this area, usually they have really, really strong stakeholder management, or at least the managers in that area will be really good with it.
Okay, thanks.
Okay.
Thanks a lot.
No worries. Okay, so for the middle column, how should we arrange the store layout to maximize sales, improve customer experience, and make best use of the space? So this is actually really cool because within Woolworths, at least, they had what we called planogram data. So this would be like, imagine for each store, for each aisle, for the 4 different levels that you might have in the aisle, you would actually be given data to say this SKU is here in this quantity. Or like, I think they have different things with replenishment rates and different things also, but it would be really like granular. It's almost like supply chain data within there, where you would know, like you guys might have heard how you usually put high profit margin items in the middle one where people can see it, so they're more likely to pick it up. So little things like that is what a lot of the store layouts, or in terms of the very granular level, that's where it can go down to. But a lot of the store layouts is more at it's again looking at that store clustering style approach. So some stores in more affluent areas might have a different style of layout compared to other ones in, let's say, less affluent areas, for example. Also for different ethnicities, there might be different groups of aisles or products that are grouped together within a certain store to make it easier for their customers to purchase. So a lot of this is more around customer experience, but there's also a very low level profit optimization aspect to this, especially when they were dealing with new store rollouts as well. So in different parts of Sydney, they're actually trialing a different kind of store layout, which kind of feels more modern. I think they had other things where you can kind of, they're trying to mimic like an Amazon Go sort of thing. So you walk around, pick up your items. I think you have to scan it with your mobile app or something, and then you just walk straight out, which is pretty cool. But a lot of the data science teams also help with the experimentation design for how they actually roll out some of these sorts of initiatives also. Okay, and for the last one on this range optimization, this is also kind of like a supply chain sort of thing also, but can we predict future stock levels to reduce fresh food waste and other cost? This one was really cool because my mate worked on this specifically last year, where they built some sort of automated system across all the different stores where they would track the stock levels of fresh fruit and vegetables. And once their recommendations would come through to the different stores, and it would recommend, okay, this store, mark down your tomatoes to this price, or after a certain amount of time, based off when the stock deliveries were happening. I think they were smart enough to even incorporate weather and temperature, which is really cool. But I think the focus on these sorts of initiatives was always on the cost reduction. So they how do I put it? They sold more of these products that they would otherwise would have trashed. So there's a clear uplift in how much money they saved by making more money by selling those products. So a lot of effort by the data science team within their side was to design the metrics and the measurement to actually calculate what was going on within these experiments to then give them more power to do more of them across different areas. So I think that was really cool for me. I think food waste is like huge. Like I didn't get the actual number of how much food people actually throw out from supermarkets, but I'm guessing that it's like in the billions worth of dollars. So it's something which is pretty important.
Danny, I have a question about this forecasting. What granularity is this done at? Is it SKU? Is it category? I'm not sure whether I understand.
I believe it was at SKU level. So it'd be store and SKU level. I think almost either weekly, or they might have even done it at daily scale. So this is like really, really large scale sort of forecasting. I think they were just using very simple time series models, but they would do it in a very robust way and actually deliver those recommendations on time for the store to actually action. So it was really cool. Like I think it was like a textbook example of how you would run like a big data forecasting problem.
These would be like hundreds of thousands.
Oh, it would be like in the, I think it would be like hundreds. Oh, the SKUs would be, they're definitely in the hundreds of thousands. I don't think it's in the millions. But with all the combinations of the stores and as well, like we're talking like really large scale, like maybe like a few million, few hundred million every day, something like that.
I'm not sure whether you are able to give some kind of ROI on this use case. I assume like you'll be millions of dollars saved, right?
I would say so. I didn't actually ask my friend how much money they actually made from it, but it would be like really, really big. Like all of anything to do with supply chain, stock optimization, and like cost cutting for waste is usually in the at least tens, if not hundreds of millions of dollars. When you think of it annually, I would say for sure.
Cool, thank you.
Okay.
Hi, Danny. Sorry. Would you recommend to separate, for example, that fast-moving consumer goods as well as slow-moving? I mean that you separate the models, or you will suggest that we build a single model to cover all the SKUs? Thank you.
So for most of this talk for the range optimization, I know it from a supermarket's perspective. So they're mostly fast-moving goods. So like all your consumable items and different things like that. There is also range optimization for the slower moving goods within not the food, like not the supermarket retailers, but for let's say Big W or Target or different things like that, where they might be selling, I don't know, air conditioners and beds and all these different things which are actually slow moving. For these ones, I'm sure they use forecasting as well. Most of my experience is to do within the supermarket realm, but they would definitely have different models. So you would have a different model for the different type, or the different business unit would have different models for sure. Usually we wouldn't bundle SKU data across the different, they called them banners, but across these different business units. Sometimes if you had a customer-wide thing, so for a lot of these different business units, they tried to match back their customer data at the customer ID level, so then they can have a better understanding of, okay, Jesse shops at Target, he also shops at Woolworths, he also buys petrol from Caltex, or the different brands that they own. So then they can get like almost like a customer 360 view, and then they can use that data for different things. So sometimes we saw that in the financial products that they were trying to target people for, to try and predict who's going to take up health insurance or different things like that. We would use sometimes they would have the models would generate some sort of output, and then we would use the output as another feature for some other model that was going to predict something. But generally speaking, when we think of the forecasting, they would definitely have different models for different products across different banners or stores and business units for sure.
Yeah. Okay. Thank you. Thank you. Got it.
No worries. Okay. Yeah, I'll move on from the range optimization. So logistics and supply chain is something which I don't have experience in, but it's something where intuitively it makes a lot of sense to actually use data science within this space. So this is me just kind of making stuff up about supply chain. So a lot of the times, we talked about, Puneet asked that question around the shopping insights for category managers, for negotiation and different things like that. So I think Quantium, when I was working there, their marquee product was actually exactly this thing. So it was like a business intelligence thing that they built in-house, where all of the category managers would have access to it, and they would be able to use the insights from there to say, Jesse, your product that I've been buying from you, my customers aren't buying it, so give me a better price, or different things like that. But it would aid a lot to have better efficiency in terms of the buying process, to make sure that you're buying the right products for whatever customers were buying from your category. I think the issue with a lot of this analysis is that it's not done at a customer level per se. Nearly everything is done at a SKU level, which is, it makes sense for the business, because the business units who are managing those types of optimizations, they don't do it at a customer level. It's very complex to think of, okay, a customer buys in my category and Jesse's category and Clifton's category. How do you make all of them play nice together? It's very difficult. So most of the time, all the analysis is done at usually at a SKU level, if not aggregated at multiple levels. But it was definitely a use case. It's more around data analytics and less about the machine learning. But I think at the time, they actually did quite a lot of sampling, subsampling to make sure that their systems are running fast, because they didn't want to constantly update daily with, let's say, 7 million customers worth of transactional data every day. So they would have these sorts of sampling strategies to make it run a bit faster. The middle one, analyze distribution center locations and trucking routes. So this is like, I'm sure within the logistics area, they do a lot of this. Like you can imagine like traveling salesmen and different things like that, where you can just apply out of the box solutions to make it happen. But I think that there's something to say around optimizing the distribution centers, as well as the products that actually get sent from these different areas to different routes. So if you can optimize like, okay, these types of stores need these types of products, you can really drastically have a huge, like high leverage impact on these sorts of costs. And for sure, like within retail, a lot of the cost comes in from actually getting the product and then getting it to the right place at the right time. So anything which can cut costs, like you might have seen in like overseas in Amazon, they do this a lot. All of the different Chinese online retailers, they do this also, where they're using like crazy robots and everything to just cut down on time and make it more optimized. So I think this is where we're going within Australia, but we're not quite there yet. And when we think of delivery, there's more and more, they're starting to have the fulfillment. So they'll have like essentially blacked out supermarket stores, which is just a massive warehouse. And you would just have warehouse workers coming in and packing deliveries. So this was where most of the online orders are being fulfilled. But every now and then you can imagine, okay, if the stock has ran out in the fulfillment center, where do you get the product from? So I think a lot of the focus within the fulfillment and the replenishment space is mostly around just having as close to real-time inventory levels as possible. And this is quite a complex problem, because you need to get it working not just in the warehouse. You also need to make sure that your staff are logging it properly. Do you automate that process? Do you use robots and different things and vision applications to actually track all of that for you? Once you actually get that data, how do you process it to make sure that digital gets it at the right time, as well as all the different stores get it at the right time? And then can you then apply more on top of that data to then route efficiently which orders go to which stores for fulfillment? So it's quite a complex space, and it's really interesting. I think there's definitely a lot of work within that space. It just hasn't quite yet happened in Australia, I think. But every time we went to those big management meetings, they would always talk about all these like smart applications and robots and all these different things that they wanted to use to optimize the process and cut down on costs and free up people to do other things. So I think it's coming, but the technology to do it either isn't present in Australia, or the market hasn't moved into Australia to actually capitalize on this yet.
Then quick question on this one, because as you mentioned, this is a really hot topic, and all the concept of cloud warehousing because of the disruption of Amazon. Like, according to you, what markets or probably retailers have actually done really good progress in this space?
I think definitely Amazon. Amazon's doing really well for that. Like I think their whole supply chain system in the US is like best in the world. If I think Alibaba and some of the other Asian players might have like they would be on par, but in Australia I can't, like the fact that we haven't heard of many of these companies doing really well in Australia kind of signifies a big opportunity to actually make something happen. So whether that's like for the technology is there, but they don't have the people to implement these systems, or maybe the people who want to implement these systems haven't moved to Australia and haven't worked with the local companies to actually do the thing as well. But yeah, there's a huge opportunity, and I can only imagine how much money would be on the table for these sorts of things, because you're talking like easily hundreds of millions in cost savings for just one sector, if not billions, over like annualized. I don't know. It's just like a lot of money. Like, so yeah, it's a really interesting space. I wish I'd had more experience and exposure to it, because I think some of these problems are pretty interesting as well from a technical perspective. Like there would be more like broad optimization problems as opposed to we need to target this customer for something, which is not as fun as doing these sorts of larger systems optimizations.
Right. Okay. All right. Thanks a lot, Danny.
No worries. Okay. So I'll move on from this side. So put a witty title here. The customer is always right. Most of the time. We actually sent out quite a lot of surveys, usually through email, but there was more and more going through like pop-up modals within the website, as well as push notifications on the app. But I think they also did like they also have focus groups. So they pay people to give them they pay people to kind of come in and give their whatever their thoughts are on Woolworths and the different brands as well. But a part of me always thought that there was always going to be a massive selection bias in who actually wants to do those things. So I never really paid much attention to that sort of data. But some people think it's really good. But most of the time, the big focus would be on NPS or Net Promoter Score. They would try and look at some of those free-form text fields, do some sort of sentiment analysis, throw it into some sort of like NLP models, and to see what comes out. Yeah, most of the time you would get like all of these different questions. People would try and look at the trends within different sub cohorts that they sent out the survey to. But a lot of it was mostly just like your regular statistical analysis. And I wouldn't say it's so much machine learning, data science specific, but sometimes these would be, you could actually use these for really important things where you use them to identify breaks in customer experience. So I think this is where we used it a lot within CBA, within the digital team. We would actually set up all these surveys for new digital experiences to see if the customer experience was actually good going through something that we just deployed. So I think this is where they can use it a bit more. But yeah, for now, surveys are surveys. You're going to get data. Not all of it is going to be clean. How do you deal with it? All of these questions is why I usually avoid surveys as much as possible. For me, anyway. Okay. So I touched on this briefly, but a lot of the data science would also be being used to enhance some of the digital product development. So you can imagine like the mobile app we talked about, the online website we talked about, there's going to be features on both of those different products. There's whole new apps as well. So I talked about for Woolworths, they're trying to do like an Amazon Go thing. We just kind of walk in, scan different things and walk out, and they charge your credit card. So all of these different things, as much as I'd like to say that they use a lot of data science and experimentation design to roll it out and get the insights that they need, most of the time, the data science and the data analytics and all the tracking is important, but not so much the analysis of what's going on. Usually that's left for like a V2 or a V3. So usually when things like this ship for an MVP, none of that stuff is ever being used. But I hope that it changes in future, because you can imagine like if you get more data and you set up all your reports ahead of time, and also you have all these highlight areas that you want to actually deep dive into, it would make things much more streamlined, and then you can kind of roll it into your next iteration much faster than if you had to have custom data science projects every time you got the data and then you had to make a decision, and it just takes a lot of time. So yeah, hopefully there's going to be more efficiency in the future for that. I talked about theft as well, but this is a number that I got online. I don't know if it's correct, but they said there's like, in retail in general, there's like almost $10 billion is lost annually. I don't know how they actually estimate it because that's pretty hard to estimate, but we'll just go with that number. Within Woolworths, they were trying to do, they actually installed cameras on top of the self-service checkouts to try and capture some streaming data to see if they could do anything with it. I don't know where they really got to it with that, but I would think that they would go to a vendor to get it done for them quickly. But they also have the thing where if you scan a certain product and you don't put it on the weight scale, it just like stops you from doing something, which is really, really annoying. So I think they were using some of the data science team to actually go in and optimize some of that to have a better customer experience or to have less theft or different barriers in place. But a lot of these, there is, I would say there's a lot of opportunity, especially in the video analysis and different things like that. But I think in Australia, we're a few years behind in that sense.
Sorry, a quick question. Usually, do people steal groceries? I thought there will be, like the theft will be more on like higher value products.
So there's a really funny thing where the number one most purchased product in Woolworths is actually bananas. So everyone just literally just weighs everything as a banana, which is usually $1 a kilo, and then they just scan it. So it's like, it's really dodgy theft like that. It's not just walking out of the store with a printer or something under your arm. That is usually rare. It's more around like scanning items. Like say you bought a really expensive fruit and you just scan it as the cheapest one.
The thing about that is that you can deny, right? Like, because say, oh, I made a mistake. Yeah, you're right.
So so it's pretty interesting. There's I think all of the chips are stacked against the retailer for that one because like most people are going to get away with it. So I think some of the streaming stuff might help. So if you have all these sensors and video cameras everywhere, that's giving you some data. But then again, it's like, because you don't know the cost of the current theft, you don't know how much money you're actually saving. So I would say this is more of like a measurement problem. If someone could actually measure it properly, they would have like a really good solid foundation to actually run a project also.
Yeah, cool. This sounds really interesting. Thank you.
I'm starting to run out of time, but we'll just talk about chatbots. Honestly, from my perspective, you don't need chatbots in retail, like unless if you're Amazon. But even then, probably the system's like way too complex to actually get anything done properly with an actual chatbot. So you're better off just hard coding if-else rules. But yeah, I think chatbots is not going to be a thing within retail, not anytime soon in the way that chatbots are being built now. Maybe in the future, if they were smarter and they actually replace people, you might have like a robot flying around the store answering questions, maybe, but who knows? And the last one is smart robots. So yeah, there's a lot of different things going on. I'll just quickly rattle through some of these. One of the ones which I thought was really cool was augmented reality. So let's say you have your mobile phone and it gives you a map of the store. And if you have your shopping list, it'll actually tell you, okay, kind of like a treasure hunt. Like, okay, go here to pick up beans, go here to pick up onion, pick up some mints, pick up some spices here. And then it would maybe recommend you a recipe. But it would be, all of these sorts of applications are usually for better customer experience. They're not so much about like optimizing at a store level or some very low level optimization, which will be very leveraged. But I think some of them, maybe like the automated truck deliveries and unpacking, maybe if there's self-driving trucks and more robots actually go in and unpack the thing, because I think that's where a lot of the people cost is. It's actually behind the scenes when people are putting the product onto the shelf. I think camera feeds and different things, like I think sensors will be a thing as we get more and more connected. So IoT and sensors should be a thing. I put in one thing about customer tracking. So because of the pandemic and different things like that, maybe you might want to track customers at an ID level. Maybe it's a little bit creepy, but it can be done. I also added in here real-time price matching. So this thing is usually like probably the biggest thing when it comes to competitive landscape for retail, is that there's a lot of competition. With like Woolworths is always fighting against Coles, for example, in Australia. And if you could do some sort of smart matching of different things, like if I could get everything at the same price as I could at Woolworths for all of the products that are on special for Coles, I would just go to Woolworths, because then I don't have to switch different stores and waste my time. So I think all of these sorts of things, like again, most of them are focused more on customer experience, which is important. Like I do think if you get the customer experience right, all the customers will come towards you, or at least more of them who are more convenient to actually travel to your store. But yeah, I think in general, a lot of it is customer experience and less so about automation and optimization and cost cutting. But I could be wrong as well. Maybe there's more robots around the corner that I haven't thought of. And I think that is it. So I hope you guys got something out of this session. I kind of ran through a lot of things. Hope I didn't lose many people.
Danny, I think it's fantastic. It's very interesting. We have maybe a minute or two. Can we have a few more questions if there are?
I have a quick question, Danny. Can you share some lights on the use cases around or problems around promo optimization, and how would you actually use data science? Because that is also a function of, again, category managers and the supplier negotiations and all those things. So can you share a bit more details on that?
Yeah, so that's definitely a really good point. Most promotions will be ran definitely at the category level. They'll have all these like schedules and plans for like 1 to 2 years ahead of when they're going to put certain products on discount. It's always like a big fight between the analytics team. So it wouldn't necessarily always be the data science team predicting when they should go on promotions. But a lot of the time, what I saw was mostly the analytics teams would try and work closer with these category managers and give them more insights to help them plan their promotions better. So at the moment, until they change their culture to actually being more data driven to set the promotions, as opposed to following a very strict guideline of we need to put this on promo here and there and whatever, I don't think it'll happen overnight. But I think with really strong data leadership across the whole organization, you might be able to change that thinking to get the data people in the room when they're actually doing the planning, or at least maybe have areas or times where you might want to have these ad hoc sort of promotions. We saw that starting to happen within the promotions realm, where these products, 50% of the time they would follow the plan, and then the other 50% of the time they might follow recommendations from the data science team, which is pretty interesting and good to see. But yeah, I think it's an evolving space, and I think the more data driven it gets, the more efficiency that they'll get out of the system. So hopefully we'll see some good things in this space.
All right, thanks a lot.
Cool. Danny, thanks so much for your time, and have a wonderful day ahead.
No worries. Thank you so much for having me.
Bye, Danny.